Hello, everybody. This is Mr. Kusaj. Now we're going to do notes 1-4. The title is Extrema and Average Rates of Change. Make sure you get the date right, please. This is the incorrect date for you. Make sure you get it right, please. Okay. First, well, let me show you the whole thing first. Let me scare you. Ooh, okay. But it's quite easy, right? In explaining it, we have to include all these diagrams and notations, but it's quite easy. Basically, increase means when your graph goes up. When your graph goes down, it means decrease. And sometimes it doesn't do neither, so we call it constant. Now, what's actually happening when it's increasing? Well, if your first x is smaller than your second x, like for example, this is 1 and this is 3, and your graph goes from small to big as well, then it must be increasing. Right? That makes perfect sense. I know there's a lot of symbols here, but all it's saying is if your x is smaller, if your first x is smaller than your second x, and your y is smaller than your second y, doesn't that mean it's getting bigger? Another way of saying is as x gets bigger and y gets bigger, then you have an increasing graph. Increasing graph. However, as your x gets bigger, if your y comes down, right? If your x goes from small to big, but your y goes from big to small, right? From big to small, then we have a decrease, right? And obviously, if your x goes from small to big, but your y stays the same, that's called constant. Your y stays the same. Your graph stays the same, right? That's called constant. Now, the reason we point this out is that's how we check. If we had the function, the actual equation, right? And we put in a couple of x's, and the x's go from small to big, and what you get is answers that go from small to big, then you're talking about increase. However, if your x's that you put in there go from small to big, and the answers come out big to small, then you're talking about decrease. So that's why we talk about this, because we're actually going to use them when we see equations, like right now. Okay, so here is a function, right? Here's the function. Here's the graph. Obviously, it's going down. It's constantly going down, right? So it's decreasing. It's decreasing forever. As x comes in from the left, negative infinity, and x goes to positive infinity, it's decreasing, right? That's obvious. You can see that. But suppose you're asked to prove it. You have to prove it numerically with algebra, right? Support. How do you support it? Well, choose a few representative x's. That kind of means any x's to show that it's going down, right? Why don't we choose some simple x's, like 0, -1, 1, right? 0, and then 2 on either side. So notice that the x's go from small to big. Now, we're going to plug these three in, and what should your y do? What should your y do? Your y should go down, right? So as you plug these in, look, positive 2 goes down to 0, goes down to -2. So the x is going up, the y is going down. That's this situation, which is decreasing. So you show that this is decreasing. Okay. Next, we want to talk about something called extrema. That's kind of easy too. Extremas are the point the one point where the graph changes behavior, right? So here, if you look at this graph, goes up, then comes down, and then changes again, goes up, and then comes down, right? So these points are called maximum. And obviously these are called minimums, right? Comes down and then starts turning again, down, turning again. This changes too. But unfortunately, this doesn't do what the other two do, right? It doesn't change directions. It still keeps going down. But there is a change of behavior here. So we call that point of inflection. So maximums, minimums, point of inflection. Now, if you have two maximums and you happen to have the highest one in the whole graph, that highest one possible, the highest one in the whole graph is called absolute maximum. This is just a relative maximum, a neighborhood maximum. This is the king maximum, absolute maximum. And it works the same way for minimum. Okay? So, if you have a graph, you can just look. Now here, in this example, we're asked to estimate and classify. Classify, I mean, what's it called? What type of change of behavior? What type of extrema is it? Okay? So by looking at this, I think it's between 0 and -1, so that's -0.5. That would be a maximum, right? Here, it looks like at 1. It's happening at 1, and it's turning this way, so that's a minimum. So I say x equals -0.5 is a maximum, but relative maximum, right? Because we don't know what's happening further on. We don't know. We're not sure that this is the absolute maximum. Maybe there's another maximum coming up here. But this is definitely a maximum, relative maximum. This is, at 1, we call that, at x equals 1, we call that relative minimum, right? So notice for both of them, we have no absolutes, right? There could be more minimums down here. There could be more maximum down there. We didn't check. But we definitely know that these are max and min. You can use the word max and min. Okay? Let's see another example going back to increasing and decreasing. Okay. Here's my graph. Here's the function for the graph. Now let's just look. Let's just look. Okay. Notice that it's increasing from -infinity to -1. So as we go from left to right, it's going to increase all the way up to here, which is -1. Right? So increasing from -infinity to -1, not including -1, right? It's not increasing at -1. That's just equal to a point. The point is not increasing or decreasing. The function is. Then we decrease from -1 to 0. No, all the way to 1. It's decreasing. And then it's increasing 1 to infinity, right? So we can support that numerically by taking each one of these points, this one, right? From here to here, from here to here, from here to here. So take a few points here, take a few points here, and take a few points here, and let's see if it does what it's supposed to. So when you put these x's here, what should your y's do? They should increase. So what I did was take a few x's way out here, -10, -5, -2. It doesn't matter which x's you take, right? As long as they're on this side of this point, it doesn't matter which x's you take. So I took these x's. Notice how they go up, and I got the y's, the function, it came out to -970, -1. Oh, it goes up too. They both go up, right? So if you didn't have the picture, you would say, oh, it's increasing here. Okay, let's show that this is decreasing. So you got to get points between, right? You got to get points between -1 and 1. I got negative 0.5, 0. 0 is always the easiest point, and positive 0.5. Those 3 points. Okay? And look what happens. 1.37, 0, so this is going down. As x goes up, y is going down, so it's decreasing. And you would do the same thing here for the last part to show that it's increasing. Okay? That's it for part 1. Since you all have a book now, maybe you can turn to page 35 and look at number 1a, and that'll be our try problem that you can put in this space here. Okay? I'll see you for part 2. Bye.